the base. So here you would calculate the area of your base and double that because there's two parallel and congruent bases. And then what you could do is you could either individually add up all the rectangular sides of the prism, okay, or in this case your one unrolled rectangle. Or you can use this formula P times H, where P is the perimeter. So basically what you would be doing here is you'd be unfolding each of these rectangles and just creating one long rectangle that's the sum of this leg, and this hypotenuse. Okay? And so you can do that using this formula right here. So if we were looking to find the surface area of this triangular prism, what we would do is start with our area formula. Surface area is equal to 2 times. And now what I'm going to do for capital B here represents whatever the area formula is for that base shape. So this base shape is a triangle, so 1/2 base times height. Notice the difference here. I use capital B for the area of the base. I use lowercase b for the individual base and heights of the polygons. And then all times, or the area of that triangle, all plus the total perimeter plus the height of our solid. So here's my generic formula plugging in the correct area formula. Okay, I can now go ahead and plug in my values. So here the 2's cancel. The base of my triangle is this length 4. The corresponding height of my triangle is this length 3. Plus the perimeter. Well, if I want to find the perimeter, it's this measure 4 plus 3. What would the hypotenuse be for this triangle? It's a 3, 4, 5. If it's not something that's a friendly number, you might need to use Pythagorean theorem. But here I take the sum of these. 4 and 5 is 9 plus 3 is 12. So my P value, my perimeter is 12. And then which of these measures is the height of my solid? Capital H, the distance between the two parallel and congruent bases. And so that would be 10. I get 3 times 4, which is 12, plus 120 gives me a total of 132. There were no units specified, so I'll write my answer as square units.